A simple pendulum consists of a small mass suspended from a string that is fixed at its upper end and has negligible mass. The length of time, t seconds, for a complete swing of a simple pendulum can be modeled by the equation t equals 2 pi root L over 32, where L is the length in feet of the string. If the time required for a complete swing of pendulum 1 is triple the time required for a complete swing of pendulum 2, the length of pendulum 1's string is how many times the length of pendulum 2's string. Okay, in order to approach this problem, there are several things that we need to highlight. First of all is our stock equation, t equals 2 pi root L over 32. Got to remember that L is the length, and the length of time is t in seconds. Pendulum 1 is triple the time required for a complete swing of pendulum 2. And we got to remember what we're looking for. So let's highlight what we're looking for. The length of pendulum 1's string is how many times the length of pendulum 2's string. And I think we can make that a little easier to look at. Highlighter settings, yellow. Okay, that's not what I meant to do. The length of pendulum 1's string is how many times the length of pendulum 2's string. Okay. So in order to solve this problem, we're going to have two versions of this equation, t equals 2 pi root L over 32. For pendulum 1, we're going to address two variables, t1 and L1. So pendulum 1's equation is t1 equals 2 pi root L1 over 32. Okay. And then for pendulum 2, we're going to do the same thing, except we're going to do it with T2 and L2. T2 equals 2 pi root L2 over 32. Okay, so remember that we're given that pendulum 1 is triple the time, or 3 times greater than in time than pendulum 2. So T1 equals 3 times T2. So now what do? We substitute in these equations for T1 and T2. So T1, for T1 we're going to put 2 pi root L1 over 32 equals 3 times 2 pi root L2 over 32. Okay, so that's what we've got so far. If I could make this look a little nicer, that would be better, but yeah, you get the picture. So now what we do is we simplify this right side over here. 2 pi root L1 over 32 equals 3 times 2 is 6 pi root L2 over 32. Undo that. 32. Okay. So now that we've got that, we can tell that the pi's can cancel out. And we're left at 2 root L1 over 32 equals 6 root L2 over 32. Now what we've got to do is we've got to solve for L2. So when we divide this equation by 6, divide by 6, we also divide this side by 6, we get 1/3 root L1 over 32 equals root L2 over 32. Unfortunately, my L2 looks more like a 12, but you get the picture. It's an L2. So after that, we have to square both sides. So when we square both sides, we get this squared equals this squared, we get 1/9 root, sorry, the root's taken out now, L1 over 32 equals L2 over 32. The next thing you do is you multiply this side by 32. So when you multiply by 32, you multiply this side by 32, the 32's cancel. And you're left with 1/9 L1 equals L2. And when you simplify that, when you simplify that from the standpoint of how many times L1 is, then L2, all we have to do is divide by 1/9, which is essentially multiplying by 9, and L1 equals 9 times L2. So, our question asks us the length of pendulum 1 string is how many times the length of pendulum 2 string? Well, if L1 equals 9 times L2, the length of pendulum 1 equals 9 times the length of pendulum 2, so our answer is J. So that was a pretty tricky problem. So let me just run you through the process again. We have an equation, t equals 2 pi root L over 32. We have to create two versions of the equation, one for pendulum 1, one for pendulum 2. Pendulum 1 uses variables T1 and L1. Pendulum 2 uses variables T2 and L2. And after that, we use the fact that the time is for pendulum 1 is triple the time of pendulum 2. So T1 equals 3 times T2. And then we substitute in what those values equal. And from there we just solve. It's some intermediate level algebra, but it's doable. So thank you for joining me today for this tutorial. If you have any questions, like always, contact me at debarshikunduzero@gmail.com, debarshikunduzero@gmail.com, and please don't hesitate to subscribe. Thank you.